Alright, in this video I want to talk about collectibles. In most of the games you have some kind of collectibles, so something you can pick up and you can store it and then you can display that. So in my game that I'm currently working on, I have carrots. You can see in the right top corner I have 22 carrots collected, and I have a few carrots here in front of me. So if I collected one, I have 23. So how we can achieve that? We can achieve that in many different ways, but I will talk about a proper way to handle that kind of things. Escape the simulation here, we have the carrot here, and let's first thing first see how it is all set up. So I have my game mode here, and in my game mode I've created a HUD class. So I have a Spring HUD, which is basically a new class. So what you need to do is, if you want to have your own game mode, you can go File, you can go Edit and Project Settings, and in here, if you have Maps and Modes, you basically have a game mode selected. So the default game mode is this one, so you can create your own and you can select the classes for different things. So what I've done is I've created my own class for HUD. So you can create a class for HUD, and this is what I have. What I've done in that class is on begin play, I've created a widget and basically I added to the viewport. So this widget WB HUD is just created and added to the viewport. That's it. So the game mode and HUD just set it up and put it on the display. So it will be on the display all the time. All right, so this is set up there, and I will show you how this UI looks like. So if we go to the designer here, what I have here in the right hand corner, I have image of a carrot, and then I have that text here. This is variable and I want to change that dynamically. So this will be bind to the number of carrots my character collected. In many tutorials online, I saw it like you can bind values here. So basically you have a content text, which is by default 0, but this can be any text here. And you have icon here for binding. So basically you can create here and you can create a binding. This is really bad idea. So if you will see something like that in the tutorial, don't do it, because that means the binding will trigger every single frame in your game. Do you need to check the amount of the carrots every single frame in your game? No. So that if you will do that, that means it will slow down. Also, you don't want to have it on tick, and because that will be used resources that you have in your game for no good reason. So basically what we want to do is we want to update that number only when we change the number of carrots. So how can we do that? Also, there's many different ways how we can do that, but I will show you what will be not maybe the best, but what will be appropriate in our case. So let's start from the beginning. So we have a carrot here. So let's see how our asset looks like. So we have here a static mesh, and then I have a sphere. That sphere basically is our collision component. That means wherever we have that collision, we can do something about it. So I will have that carrot in my world. If I detect the collision, I can do something about it. So basically what we have here is we have on component begin overlap. You see that sphere. So that means when we overlap with that, then we can do something. At that point, my carrot could send information to the HUD. What I could do here is I could have my player control, I could have my game instance, I could have different things, but I could actually access my HUD through my game mode, and then HUD and this controller, and I can update it from there. But this wouldn't be optimal. And why is that? If you program something, you don't really want to have responsibility for collecting carrots or having state of how many carrots you have in the carrot itself. This carrot might be something else. So if you will add extra collectibles in the game, it shouldn't really hold a responsibility for what it's supposed to do. So the best thing will be carrot will handle the beginner overlap, and it will send that information somewhere. And if you want to do something with that, then you can do it in that actor. So what we are doing here is basically we're sending that to our character. Our character is BP Spring here. So normally what you can do is you can check like, oh, what is overlapping with my carrot? And other actor you could do is casting. So casting is not really the best way to handle interaction between the actors, because if you will cast here, cast to BP Sprig, this is my character. This will add extra size to that blueprint. So whatever you put the class in here, like you've done here, so if you want to check if the other character can cast it in here, so basically you could do that. And then if it does, then you will have that character. That means that character overlap with our carrot. But we don't want to do that because that will add an extra size to a carrot. So if you do that in every single blueprint, it will just grow in size and it's not going to be optimal. So casting is not really optimal. It is possible. It's not a bad thing, but maybe not in our case because our spring character will be quite large. So adding that to every single collectible in a game, that will make it less efficient. So I'm not going to cast it here. What I want to do is I want to use interface. So let's take a look at the interface. We have a Sprig interface. Sprig is my main character. So on my interface, what I have is I have carrot collected. That's a simple function. If you want to add extra function, you can add a function and you will have it here. So let's say new function here, and you can decide how many parameters you want to add, like input and output. For my carrot collected here, I don't have any inputs and outputs. I don't want to send it anything. What I want to do is I got carrot collected. It's a simple notification there. So in my Spring AI will remove that function here. So I have that carrot collected. Basically, it's just a simple function. That function is implemented here. So my BP Spring, if you go to class settings, what you can do is you can implement interface and you can add that interface here. So you can see here, Sprig interface is added to my BP character. So this is my BP character. You can see here that's my main character and it has implemented that interface. That means if you have it in the class setting added to that interface, that means on the left hand side, if you expand the interfaces here, you will have carrot collected here. That's a function that is coming from that interface. So I can save this and close it for now. So we have that function here. If I will click on it, this is what I've done. I have if the carrot collected, then do something. So if you go back here, what I've done here is wherever we begin overlapping with a carrot, we check if the actor that we are overlapping has that interface, and we are looking for a Sprig interface. It does, because we know that our main character in the class setting has that interface implemented. Then what we do is we check it if it does, and then we call on that interface carrot collected. So you see, we don't need to cast into our character here. We just want to say, okay, trigger that function, and we don't really care. We play the sound, and then we destroy actor. So basically what we've done is whenever we touch that carrot, we've checked if the actor that touches has that implemented, and we send that function and remove that actor altogether. So the carrot will just disappear. We'll send the information to that interface, and then it's gone. So what we have in that interface, so basically we implement that interface and we can have some functionality here. And this is a place where we can actually make any decision. So you could have in your character, you can have some components that will be responsible for inventory. You may have different things in here that will be responsible for collectibles. But actor can spawn and respawn and can die, can be put in the level. So every time you go to another level, it will spawn there. So all the information you have there, the variables that you will hold it, might not hold it in between the different levels. So you need to make a decision what you want to hold as information. So in my case, what I want to do is I want to track the number of carrots collected across all the levels, everywhere. So for me, my decision was I will put it in a game instance, because game instance starts when we start our game and it will last to the very end. So what I want to do is I want to have different levels and so on, but I want to track the number of these. So I have a game instance that I also set up in my game mode that I'm using this one. So basically what I have is I have variable here, carrot count. And so if I go here, you have that integer. So basically when I start my game, I just added 22. That's why you see 22. But basically that carrot is just a variable that is stored in my game instance. But From my spread, whatever a carrot collected, I got that from the carrot. What I want to do is I want to say get my game instance. And by the way, this is a global function. So if I click on this one, what I've done is I've created few global functions. Normally you have a game instance, you say get game instance, cast to game instance, and then you will have that game instance, because the game instance will be just a reference to a game instance. We need to know which class of game instance you are using to access its method. So basically you need to have two of those nodes here to have your game instance. But game instance is very small. Despite the fact we cast it into it, it's not going to be like a real actor. This is very little comparing to other things. It's just few variables in here and there is not much more functionality. So even if you cast to it, you are not gonna put extra size to it. So basically, if we go back here, I have that global function, get my game instance here, and it will just get the game instance, cast to it, and return it. So it's easy way for me to go back into here and then just use it one simple function. Basically, that function also I mark it as get my game instance. I mark it as pure. So that means you don't actually even connect the execute pin to it. So you see this one is it doesn't have to be connected to the execute. It's just it will get the game instance, it will be already casted to that my game instance, and I can use some function in there. So in my game instance, you see I have a function that I can use from here. So my VP sprig, I could do some logic in here, add to my inventory, but I decided I'm going to put it in my game instance. So I will have a function add carrot. So if I would click on this, I am in the game instance here, and I have carrot here, and I have function add carrot. So basically my character will trigger this function. Basically what I've done is I just incremented the carrot count by 1, because I know I'm not gonna increment it by more amounts. You could actually have some inputs in here that will tell you how many carrots you want to add it, but I know for sure that I will add only one at a time. So I'm just setting a carrot count here, and then I have even dispatcher. So basically what I want to do at the end of the day is to show it here. So what I will do in my game instance, every time I change the number of carrots and I add one, then I do call on carrot count change. I have here a event dispatcher that you can create. You can create a new event dispatcher in here, and so I will leave it for now. So basically you have that on carrot count change, and that's a dispatcher that will send that information. So basically I will send information how many carrots have been collected, and wherever I add the carrot, I dispatch that information. I just dispatch it to whoever will be listening to that information. So that's the key functionality in between my storing the data here. That will be global data that will store it in a game instance that is not going to change. So it will, whatever I send from any actor in my world, I will send it here and it will be stored as a carrot count. And whatever I've changed, I call it. Carrot count has been changed. Whoever is listening to that can have the information how many carrots we have at the moment. So that's what we've done here, and you can see here I can add inputs, and that will be used there. So basically what we need to do as a last step is going to our blueprint. We want to have that updated, but we know that our game instance holds that information, and whatever the number of carrots change, we can actually listen to that event or that event dispatcher and change that amount there. So if I go to graph here, I've done a few things. So if we pre-construct it, we set a few things, but this is the bit that we are interested in. Basically, I have my game instance. So you can see here, this is what I've done, get my game instance and set it as a variable. So I have that in the variable that I can use it anywhere in that blueprint. And that variable, what I can do is I can bind event on carrot count change. So if you have that game instance, you can see here, I set carrot change. I can have access to that event dispatcher. I can call it, I can bind it, I can assign and so on. If you bind it, that means you're listening for any information that is coming from there. And as we remember, if we go to game instance here, this is when we call it. So if we add one carrot, we call it. That means if we bind to it, we can create an event. So if you normally you will have it like that, and then you can create event here, and you can decide it what you want to do, and you can create the event and so on. So card collected is the one that I want to use, so card collected, or you can create a new one. Basically, you listen to that event with a bind, you create an event that is card collected, whatever this is here, and that will be triggered. So basically what I've done here is I have that my text, so go here, text carrots here, then that text, you see that txt carrots here, basically this one, and we set that into whatever is coming from that dispatcher. So carrot counts, you can see here, this is basically what I have here. So in my event dispatcher, I provide that information. So if you go here and you bind to it and I create an event, this will be available. So basically I get whatever is there in my game instance and I set it as a text in my user interface. So important takeaway from this is you don't want to have it on tick, because tick will run frequently. So it will run and use a lot of resources because it will need to constantly check it. So you don't want to have it binded here. You don't want to have it on tick to check it. What you want to do is you want to update it only when it changes. So you need to decide it where you're going to change it. So you can store it in the Sprig character in the inventory system, whatever you like. You can have it in different places. I pick it in the game instance because that's where it was my decision that I want to have it hold it between from the beginning of the game to the end, and then I just dispatch the event that's been changed, and whoever listened to that, it will update it. That's very convenient way to handle the data, and also convenient way to pass the data from one place to another. So the full loop is we go from carrots, we check who is overlapping, we send it to our character say, okay, I got a card, send it to my game instance because I want to add it to my storage in a game instance will trigger an event, and I'm listening for that event in my HUD, and I will update the value there. And it's very optimal way to handle that kind of things, because it will trigger only when we collect carrots, when we overlap with that sphere here. I hope that helps you to think about it, how to store the data and how to manage the data in between different actors. Thank you, and see you in the next one.